who is managing your server, who will be managing your server. You just focus on your development. That's the serverless architecture. Thank you everyone and welcome to this tech talk. And we are going to start with the first topic of the today, that's serverless architecture. And if anyone wondering if I'm going to talk about some hardware or something, that's not the thing we are going to talk. I'm not going to talk about DevOps as well. I heard someone said I'm going to talk about DevOps. The topic is totally related to development. It's not something DevOps or some server hardware I'm going to talk about. It sounds like some confusing, but that's not the things we are going to talk about. So first thing we have to, when we are talking about serverless, does that means no server? Okay, first thing I'm going to ask everyone, make this conversation, like discussion, interactive. You have any confusion, just throw it out, don't hold it, and I will try to like answer this. There will be, might be distraction, we might diverted by that topic, but we will try to like, can someone just note down that question, and we can come back another day on that topic. So there is no like, it might be a stupid question, should I ask or not, just throw it. Okay, so let's come back to this serverless architect. So what I'm talking about, if you have an application, that application is running somewhere, so that's the server we are talking about. So you have a code you want to run somewhere, you have some computing power there, that's running your code, so that's server. But we are going to talk about that's serverless. Does that means there is no server? There will be server, but you don't have to manage that server, there will be someone. That's the serverless architecture. If you talk about any traditional, any application, what you have a front end logic, you have some security stuffs, you have some back end logic, and you have a database. So these are the part of your, that's the thing, a part of the application. Whatever the application you talk about, these four components will be the basic component of your application. So to run this application, you have a code. You first thing, let's talk about any application. You will have these four things running for you. Some front end will be there, might be your web application, might be app, and then you will have some security, which will be basically identity management or something. Some backend logic that will be basically running somewhere, and then you will have some database to persistent your data. The problem with this, so why we need the serverless architecture? First we have to understand that, because the first thing what I'm trying to explain, why we need the serverless, and then we will try to understand what serverless architecture is. So if you have an application, you will need a server to run these things, and if you know, you will need a server. It might be some container server, some containerized system, like let's say you have some Kubernetes running. Then so from the first day, if you have, like, even you are using Azure or you have your own data center, it will start costing from your first day. You have configured your server, doesn't matter, you have a customer, you are using it or not using it, you have configured server, it will start costing you from the first day. You have a database, you have configured database, from the first day you will get a start build. Either you are using Azure, AWS, whatever cloud, or maybe private cloud, or maybe you are hosting your own things, but it will cost you from the day first. Even you don't have any customer. That's the problem we are trying to address with the serverless architecture. Means if you don't have a customer, you are not using your stuffs, it will not cost you. That's the one thing we are trying to address here. So I hope I tried to explain why we need this serverless architecture. What's the problem we are trying to address here? We are trying to address the problem of the traditional system, where we have to pay for our server from the first day, even we are not using it. That's the problem. Right now, I have example in my current job. The management is saying, like, I don't have a customer, I have a 500 customer, still I am getting this much bill for my infrastructure. Does that means if I have a 1000 customer, will this bill will get multiplied? Because they are considering that, yeah, this cost is for 500 customer. If I will get 1000 customer, this cost will multiply. But we are not going to basically multiply this customer, because the infrastructure is base infrastructure. That's the cost of the infrastructure, and then on top of that we can run 500, we can run 1000 customer, we can 2000 customer. But that base cost will come, even you don't have 100 user, still that will cost you. So basically, when we are saying that the serverless computing means the computing power will be inbuilt with your the cloud provider. Though your computing power, your persistent storage power will be managed by your cloud provider. So when I am talking cloud provider, it's definitely I am talking about some cloud provider. You will not able to implement this with your own. Like if you will try to set up your own data center, that's not feasible. You have to go with some cloud provider, and they can provide you serverless computing facility. You will not able to develop everything from the scratch. So you have to choose your cloud provider, either AWS, either Azure, either Google. These are the top cloud provider these days. But there are others also, they can help you with these things. So when we are talking about the serverless computing, what we are saying? We are saying that there will be no hosting things. You don't have to think about where I will host my code, where I will run. You don't have to think about that. You just code it and you choose the service. The hosting thing will be basically solved by your cloud provider. Then they are saying elastic. That means let's say you need a computing power of 2 user right now. You can choose 2 user computing power for now, and it will be elastic. If you have 1000 user, it will be auto scaled. You don't have to think about, let's say I am having 100 user right now, let's say tomorrow I will have a 1000 user. So what I have to do? You don't have to think about that. That will be managed by your provider, whoever your provider is. Then event driven, and I don't think I have to talk much about it. Event driven means you can utilize your event driven. One system will generate the event and the other system consume. So in the serverless computing, you have capability of the event driven development capability. Then next thing is a logic, basically logo block, means you can have a small block and you can plug it and you can make your whatever you want to make out of this. So it's just like a logo block, and you can start building your things from here. And then next thing is high availability. High availability means, let's say you have a system, it should be 100% available. It should not go down anytime, and that's the promise from the any serverless computing. It will be 0 time. You can't think about that. There will be millisecond when our system will be down. You don't have to think about. But if you are in the not traditional architecture, you will have to consider how to make our system 100% available. But if you are going with the serverless architecture, serverless computing, you don't have to think about your availability of the system. And then obviously the best part, what I already explained you, the usage cost. You don't have to think about your cost from the day first. It will cost when the first user will log into your system. First user will access it. Let's say today you have 10 user, it will cost for 10 user. Tomorrow you don't have any request, there will be no cost for the tomorrow. So that's the cost optimization you can get from here. Now I think I'm able to explain what I'm trying to achieve from here. And if you have any question like something, we can address. Otherwise, we will go.
Is there any base fixed monthly?
No, nothing. There is nothing. No cost. 0 cost from the day first. You configure it. You will not get cost for anything until unless you start using it. That's what I'm saying. saying I explained you have a server, you have configured your server, you have configured something that will cost you from the first day. But if you start using serverless computing, it will not cost you until you use it.
Is the serverless computing is equal to cloud computing, or is
This serverless computing is a cloud computing. This is a service of cloud computing. I am not talking about something new. There is already cloud computing, but that cloud computing is a type of computing where is a server, physical server, where you have to manage your things. Like if you are talking about Azure and you want to deploy a system, let's say you have some 4 or 5, let's say talk about maybe your e-commerce system. So you have a services coded for, like say order service, customer service. These are the service, and you are running this. You will run somewhere, like you will have a containerized system. Maybe you have Kubernetes cluster, maybe you have containerized system. You will run this. That's a cloud computing. But if you configure your AKS cluster from day first, it will cost you. If you have make your own containerized system, you have configured, like you have created for virtual machine, it will cost you from day first. But what I am talking about, within that system, means within the Azure, within the AWS, you can use some services that will not cost you from the first day. So that's what we are saying. There will be, this is the cloud computing, but serverless computing. Okay, then can we go to the
That was a question actually.
yeah. He is also trying to participate in the
Yeah.
we can continue. So now the thing is how we can do this. We talk about this is cloud computing and how it will be benefit. So we'll learn why and what it is. But now the thing is how you can do this. What are the services available in the market that you can utilize, and then you can use that feature, and you can make your serverless computing system. So I am using a AWS for now, but it's not necessary you have to go with AWS. There are similar services available with Azure, similar service available with the Google as well. So you can choose any of the cloud provider, and you can utilize the services, and you can make your serverless computing. But I think if you compare about the cloud computing, public computing, AWS is the leading. They basically release first, then the Azure or Google follow that services. So the AWS make things available first in the cloud computing, and then other can bring that system. So for now they have the AWS have a very good services. By using that we can make serverless computing easily. But that similar services is available Azure. We can talk about that later on. But for now, if you I have to use I will to go here. There are few system over here. See, so most important part of is the AWS AppSync. Who know here the GraphQL? Do you know the GraphQL? You always know. Basically, all know the web API things. So you have a services, you can call it, and it will give you the JSON whatever response. But GraphQL is built on the another type of property. If you talk about if you compare with the web API with the GraphQL, basically it's a database. It for database which is available on internet. So right now, let's say you have a order, you have a employee, you have a product. So if you want to develop it, you will create a 3-4 API, and then UI will call the order maybe employee or maybe the product. So you have to make 4 call, and then you can bring all these data together and you can build UI on the your app. But if you implement with the GraphQL, there will be only one endpoint and then you can basically Dhruv.
No, please continue.
Oh, sorry. I don't know if I am making sense or not. But what I am trying to explain here, first component we are going to use the GraphQL, and GraphQL is implemented by the AWS with as a app sync. So the app sync is a product of the AWS that implemented the GraphQL. So you can, instead of you developing your web API, you will develop the GraphQL. So it GraphQL you can consider a database. You can just, like, if you have a database, what you will do, select a star from this and you bring just 4 field and you use it. Same thing, if you develop your web API with the GraphQL, you can have just one interface, and you, let's say if I need 4 field, I can query 4 field. If I need 10 field, I can query 10 field. I don't have to call so many API. I can just call one API. I can say give me just 2 field, and the same API, if I can say give me 4 field. So that's just one interface. With the help of the GraphQL, you can combine your all web API to one interface. I have added some API gateway as well, but this is not necessary. We can take out, there is no need of API gateway, but I bring it here because it gives the better security in terms of the GraphQL, but the security can be integrated with the app sync as well, and there is no need to API gateway. It play no role over here. And then the app sync is basically, now you have a app sync which you can expose your web API. The app sync is basically, you from the app sync there are multiple component here you see. The from app sync, let's say you have an employee, 4 field over there. So 4 field is stored, might be in database, might be it is coming from somewhere. It can directly connect to your database and it can fetch to you your data. You can map, you have to just map that field to the target. Like I have created a schema, you can consider it your table, or maybe you can database schema. That schema need to be mapped with the somewhere in database. You can directly map with your any database, like you can map with your Lambda, either you can map with database, either you can bring another, you can call another HTTP you call from here, or anything, there are any services can be mapped from the this the one field you can map and you can bring it. So, and yeah, you can call from here, you can call REST API. If you have a REST API, you can call from REST API. Here you see there is just another component SQS, and there is another component event bridge. Why we need this event bridge and this SQS? You might be having some external system, and that external system can try to push your data to your system. So this event bridge is like you can consider just simple bridge, where one side you are putting some data and from the other side you can pick it and you can process it. So that's the role of event bridge. So if a external system puts some data, we can connect external event bridge to SQS. SQS is just a queue. You can put some data and you can process by anything. You can have multiple hookup from here and you can process one by one data. So, and anything here, whatever you see, if you configure AppSync or SQS or maybe any component you see, it will not cost you anything unless some client from here make a request to your system. So, and this AppSync cost how many requests you are making. Even your database, this database is cost you how many requests you made here. Here you have a Lambda function. This is a code, but code in REST. Lambda is a code in REST. It's not running. It will run when you will hit the that system, and the time of minute, time of second it will cost you for that time only. As
Yeah, about the database, one question.
Yep.
You have glass of water. So you mean that you will pay for each request?
Request.
Does it mean that the database, it doesn't matter how big the database is,
They will not
just
cost you for a
some
store.
bytes, or if it's a terabyte,
Yeah.
it doesn't cost you?
Doesn't cost, storage doesn't cost you in term of Amazon. I'm not talking about all the database. I'm just talking about the Amazon database. Their costing mechanism is your request. How many requests you have read, you have write, that will cost you. It will not cost you. Doesn't matter how many, how big your data is. No cost.
So, as you said, it will cost us when we import data to the database because that's a request. Then each time that we get the request to receive the data, then it's another cost.
Yeah, so every time you make a request, that request price bill per request, per read, per write, that will your cost. How big your data, that is not a cost for
So
you.
for example, if we can import 1 terabyte of dot data, we pay for that request or those requests, and then it sits there and no one is requesting, then it doesn't cost.
Doesn't cost you. So let's say you have a functionality over here. We have a product listing. Let's say this is mobile app. We are trying to develop some e-com, and we are listing a product, and that product is installed here. So a user will make request AppSync. AppSync will cost one request, and AppSync will request your DynamoDB. That will cost you another. If you are running some code behind the scene, Lambda, the time of amount then it will cost you that much. So there is a no sorry, oh I'm sorry, no we have to yeah we have to basically go to the next slide because this is just on top of that I'm trying to explain because that UI was diagram was not clear, but I'm trying to say you have a application and there will be AppSync, and then you can hook up your AppSync with any of the services. You can execute Lambda function, you can execute Dynamo, blah blah things from here, but that is the capability of the AppSync, and AppSync is nothing. This is just implementation of GraphQL. If you anyone have heard Apollo GraphQL, that's the implementation of AppSync. And so the AppSync is basically give you capability of the GraphQL. Now the thing is we learn about these component. Now you will say how I will create all these things. What's the things we need to create all these things. So there is a tools called CDK, Cloud Development Kit, and that is developed by the AWS. But it's not the thing that if you learn the AWS CDK, you will bind with the AWS. AWS CDK is built for any cloud development. Through the AWS CDK you can do any cloud development, because there are multiple people trying to publish something, and the even the cloud development kit have
Yeah, please continue.
the cloud development kit have a capability to run with any cloud. I think I don't have time to go with each in detail, so I will sort out. I will have to basically wrap up this. We'll go in the detail in some other day. So basically, that CDK give you capability to develop all this system. So the CDK, when you create the CDK application, that's called app, and within that app you can have multiple stacks. Like in a stack, in one stack you can create the real component of AWS. You can create your S3 or whatever the component you just saw. You can use that construct and you can create it, and this whole app will be synthesized, and it will be converted to the cloud formation template, and then it will be deployed as the component. So this basically the CDK what I am talking about. These are the component of that CDK. I don't have time to go each in detail. I will try to bring some other day with all the details. Okay. and you can use this serverless computing with any type of business. Where that's what I'm talking about. If you have a microservices, still you can use that serverless. If you are developing IoT, you are doing some application that just data processing, you are having application that streaming the video, any kind of application can be developed with the help of this these technology. I have some code, but I will not able to say.
You can take 5 minutes. It's okay. It's perfectly alright. Yeah, that much time. Yeah, now you can. Alt tab C.
Sorry.
Yeah, it's outside.
Okay.
Alt tab. Command. Oh, sorry.
Sorry.
Here you have. Do you want to say?
Yeah, this one. So I am just having the UI. How the I was talking about that you have a database, the AWS. So you have like query, you have all the field available here. So you just query and you can pick any column over here. Like here you can see. I just want to see the member, birth and cell phone. I just made this query and just the member, birth and cell phone be available. But all the data is already available. Other client will need the other things. They can just pick. Yeah, I need this. Then they can pick this value. So basically, it's I'm just trying to explain what is GraphQL and how it going to replace your web API, and that's the future. You have to replace your web API because there is lots of problem when we talk about. You can take the other image.
Yeah, this is the other one.
Yeah, I'm just trying to see here. There are multiple objects, and the other one you just saw the attribute of that attribute, these objects. So the next thing what you will see the GraphQL things, because in the UI, if you have a web application, you have a app, you will see that you have to make multiple call to server to bring all the data, combine the data, and then present it to the UI. But if you have a GraphQL, you don't have to worry. You just make one query, just bring two fields and show it. You need a view where there is data needed from the customer, there is data needed from order, there is data needed from payment. You don't have to make 3 calls. You just make it one call. Say that I need order detail, I need the payment detail, I need the customer detail, and all can be combined at the UI level. That's the benefit we will get with the help of the GraphQL. I don't know how to change. तो सिर्फ एक बार कोड दे.
वो यहाँ पे sorry.
This is just a little example of the AWS SDK where I am trying to do some to do app with the help of DynamoDB and some GraphQL API. So first thing you will see, I have a basic. Give me back. So that's what I was talking about. You will need a app, and within app you will have a stacks. So here we have we created a Dynamo table. We are trying to basically give the permission. We are trying to add the data source for the Dynamo table, and if you talk about, we have some GraphQL schema. So we have created this schema. This is our schema, and then on this schema we hook up the resolver. So like we have added this resolver to this schema. So when someone will call, it will go to the DynamoDB and it will bring that fields. I think that's all. I will hand over to Dhruv. I had many things, but I don't think I will be able to cover.
One question: which scenarios is it profitable to use this compared to the old one?
Repeat the question once before you answer them. Repeat the question once so that it's.
Yeah, basically the question here is we are trying. What is the factor to decide we should go with the traditional computing or we should go with the serverless computing? What's the factor we should consider? I would say like if you are trying to do some startup stuff. You don't know what will be my customer base, what will be profit. I don't know the business. I just want to go with a start something start, and I want to save the cost. I don't want to pay for something. Then definitely that's the thing you should go for. So you don't have to pay for your infrastructure until unless you go with live business and you do some stuff. That's the one thing to decide with the should I go with the traditional and should I go with the cloud serverless computing. And there are multiple factors. This is the one of them. You will very soon in IT industry you will heard the new position that will be called platform engineer. There will be no DevOps engineer, because we do, you see this in this scenario, we don't need any person who is configuring your infrastructure. You as a developer configuring your infrastructure, writing code for your infrastructure, and you are writing code for your business logic. So there will be no person who is configuring your infrastructure. There will the person need a platform engineer, and that platform engineer should know the code, how to write the business logic, and how to write code for your platform as well. So that will be the like of skills you will need in near future to do this with the cloud development things. Yep. Interesting. That will be interesting. I don't know. I have many things, but I don't think I will want to cover. Yeah.
You can always set up another.
Yeah.